Hello there, good morning, and today's video lectures we are trying to see on the numerical of the virtual work. As we know, if you want to generate the virtual work, means we need to generate the virtual displacement to that body. Then automatically that body will going to be generate the virtual work. In actual sense, the virtual work done on that system is going to be 0 because there is no the virtual displacement when the body is in the equilibrium condition, but we are going to be trying to keep that body is in the virtual displacement, and then we are going to be calculating. So here is the problem of that, the two balls. So here we do have the two balls, that is the D and E. So that's going to be D as well as the E. The two balls are going to be mounted on the two bars of the AC as well as the BC, right? So of the weights of the P as well as the Q. So these the balls we do have D and the E, and their weights are going to be called here is the P as well as the Q. Can slide freely along the bars AC as well as the BC. It is not only the resting on the AC bar as well as the BC bar. They are going to be slide is going to be taking place. They are going to be freely slide, either maybe upward direction or maybe the downward direction. And similarly the same thing for the ball E also. The balls are connected by an inextensible string DE. So here the DE is going to be connected here with the one inextensible string. So find the value of the angle theta, defining the position of equilibrium position. At what position these two balls will come into the equilibrium condition? It means that there is no displacement is going to be taking place. So this theta we need to be calculated. It means that the theta between your AC and between the string DE we need to be calculated. So from this one there we can see the AC bar is going to be making 30 degrees and the BC bar is going to be making here is the 60 degrees is going to be making. So now we need to define the few parameters here. So what is the parameters here? Because inextensible string we are going to be considering here, that's going to be DE is going to be your inextensible string, that I am going to be say the L. So that means DE I am going to be called, this is going to be the L, right? And in this case what will happen, this is the 30 degrees, this is the 60 degrees, and here it is going to be making 90 degrees. So then what will happen, this DC as well as the EC we are going to be, we need to calculate that, we need to calculate the dimensions of this component. How we are going to be calculating, because this is the theta, right? And this is going to be called your hypotenuse, suppose. So then what is this? So the theta opposite angle is going to be your EC and adjacent angle is going to be your DC. In this case what I am going to be considering here, if I am going to be taking the sine theta is equal to, what is the sine theta in this case? The sine theta is going to be opposite side or is going to be CE divided by DE is going to be your hypotenuse. As we know, the DE is going to be, I have assumed the length of the string is going to be L. That I am going to be substituting in this equation. So that what is this one? The CE is equal to. So the CE is equal to DE is equal to L sine theta I am going to be considering. At the same time, the CE distance I am going to be taking in the parameter of that one, that's going to be x2 is equal to L sine theta. This is the first, suppose I have taken the distance between these two is going to be your x2, I got it. And similarly the distance between the D as well as the C I need to be calculate. So how we are going to be taking the cos theta is equal to, what is the cos theta in this case? In this triangle DEC, the DC is going to be your adjacent side and the DE is going to be your diagonal, that's going to be DE. So I am going to be further simplifying this equation. What is the DC? DC I am going to be need to calculate, that's the DC is equal to L into cos theta, right? So for this case DC I am going to be considering that is the x1, right? So the DC x1 is equal to L cos theta I am going to be getting. So these are the two parameters are going to be very helpful to find out the infinitesimal displacement from this object. It means that for this case I am going to be taking the ball is going to be trying to move in the upward direction and the ball D is going to be moving in the downward direction. That's the assumption I am going to be do. Then I will try to find out what is the virtual work. So after this one, I'm going to be shifting. That means already we told that this bar is going to be, the ball is going to be sliding on the AC and this ball E is going to be sliding on the B. So I'm going to be assuming by giving the small infinitesimal displacement. So then this is going to be shifted to this position. This is the ball position. At the same time, when the ball is trying to move this side and this ball is going to be trying to climb on the BC. So then I am going to be taking over here. So this is going to be your infinitesimal displacement. That means the distance from, suppose this is D and this is the D dash, I am going to be calling, this is going to be your dx1 or del x1 I am going to be considering. And similarly, the distance between your E and the E dash I am going to be taking, here is the dx2 I am going to be considering. So this way we are going to be considering that part. This is the dx2 is going to be your infinitesimal displacement of your ball E. So then how could you calculate the dx1 as well as the dx2? As we know, we do have these formulas. In this case, what will happen when the force is going to be acting in this direction? So that means in the same direction the ball is going to be trying to move. But in this case, opposite direction, the ball is going to be displacing. So for this one, I am going to be taking the x1 is going to be varying with respect to theta. So in this case, what will happen? This theta is going to be del theta, theta minus del theta we are going to be getting here. So that's going to be x1 is equal to L cos theta. Suppose if I am going to be taking dx1 by d theta, because x1 is varying with respect to theta, that's going to be L is going to be the constant. This is the inextensible string and the cos theta is equal to minus sin theta we are going to be getting. So then the finally this is simplification, dx1 is equal to minus L sin theta d theta I am going to be getting, because the displacement of the ball is in the positive direction, because the same direction the displacement is going to be taking. That's why we are going to be taking the module, and finally dx1 is equal to L sin theta d theta I am going to be considering. Now we need to find out the dx2 value. So the same position I am going to be taking here, then I can calculate the dx2. If suppose if I am going to be taking the dx2 means dx2 is equal to L cos theta d theta I am going to be getting. Directly I have written over there. So once we are going to be getting, then we need to resolve these forces. One is going to be normally to that the AC bar and parallel to the AC bar. These two forces are going to be acting, and finally only the one force is going to be contributing to the infinitesimal displacement. So that force into the infinite displacement is going to be, we need to be multiplying, then we will get the virtual displacement. After the calculating the dx1 and dx2 of the infinitesimal displacement of the body, now we need to find out the P which is going to be acting for that infinitesimal displacement. First I am going to be taking here is going to be the P. So in these slides I am going to be taking here, this is the C and the A bar I have taken, and here it is going to be the ball is going to be rested, and this point I am going to be say that self weight is going to be acting in the downward direction. As we know that the AC bar is going to be making 30 degrees to the horizontal plane. So I am going to be taking here is the 30 degrees. Now I am going to be taking, finding the what is the inclination with the horizontal plane. When it is going to be making in this direction, this is going to be the 30 degrees, and similarly when it is going to be, this will going to be making 60 degrees, right? Once it is going to be making 60 degrees, I am going to be resolving the forces into in this direction. One is going to be in this direction, another is going to be in this direction. As we know, to this line, and this is the line of action, and this line of action is going to be making 90 degrees, and here is the 60 degrees, and we are going to be getting here is the 30 degrees. So this 30 degrees I am going to be taking in this way. So this is going to be your P sine 30 degrees and this is going to be your P cos 30 degrees. So that means this is going to be your P sine 30 degrees force is going to be acting on that ball and then it is going to be displacing. So that force is going to be P sine 30 degrees force is going to be acting. And similarly, when I am going to be resolving this force also, I am going to be getting the Q cos 60 degrees, I will get it. And this is the main reason to the infinitesimal displacement of the body from the E to E dash, that is going to be your dx2. And now I am going to be applying the principle of virtual work. The principle of the virtual work we are going to be taking, that means whatever the total work done acting on that system is equal to 0 when the body is in the equilibrium condition. So that I am going to be taking the P sine 30 degrees dx1 plus Q cos 60 degrees dx2 is equal to 0. Right? In this case, dx1 is available, dx2 also available, but we need to find out the direction of that part. What is the direction dx1? Can you see? When the force P sine 30 degrees is going to be acting on this member and then it is shifted to this position. So this is going to be your D and this is going to be your D dash. That means the direction of the force and the direction of the displacement also matching. So then this is going to be the positive. But in this case, what will happen? The direction of your P cos 60 is going to be acting in this direction, but your displacement is in the opposite direction. So that's why I'm going to be multiplying here with the minus. So substitute in this equation the P sine 30 degrees dx1 is going to be L sine theta d theta. When I am going to be taking to the right side, that's going to be Q cos 60 degrees into L cos theta d theta. So in this case, L d theta will going to be cancelled out. Then sine 30 is equal to 1 by 2, right? And in this case also, we are going to be getting the sine 60 degrees. Sorry, in this case also, we will get the sine 60 degrees. So once it is going to be acting the sine 60 degrees, so then we need to find out the theta. So that's going to be sine theta by cos theta is equal to the Q sine 60 degrees by P sine 30 degrees. Right? Once it is going to be acting, as we know, sine 60 degrees is equal to root 3 by 2 and sine 30 is equal to 1 by 2. 2 will going to be cancelled. Then finally, I am going to be getting here the Q into root 3 by P, I will get it. So from this one, I can calculate the tan theta is equal to root 3 Q by P, I will get it. So if I know the self weight of this balls P as well as the Q, I am going to be substituting those values and then I can calculate the theta easily. Okay, this way we are going to be identifying the unknown parameters from the principle of virtual work. Thank you. So I hope you are able to understand what the concepts we have explained over here.